Assalamualaikum class. In this video we are going to solve some supplementary problems related to chapter number 2. So you have to attempt question number 55 and 56 on your own because these are quite simple and easy questions. And now we are going to solve question number 57. Find the angle between the given vectors. So we are given with the two vectors a and b, and we have to find out the angle between these two vectors. So how we can find out the angle between the two vectors? We know that a dot b is equal to ab cos of theta, where a and b are obviously the magnitudes of the vector a and b respectively. We can find out the dot product by using the method that we have to multiply the corresponding components and add the resultants, and we can find out the magnitude of a and magnitude of b as well. So at first we will find out a dot b. So a dot b is equal to a1 b1 plus a2 b2 plus a3 b3, that is 3 into 4 is 12, 2 into minus 3 minus 6 into plus 1 is minus 6. So this is going to be 0. So a dot b is equal to 0 means cos of theta is equal to 0, and we know that theta will be equal to 90 degree now. So that is the given two vectors are perpendicular to each other. For the second part, we are given with the two vectors c and d, and we will find out c dot d first. So c dot d is equal to 16, as we have to multiply the I components in j and then k. So 4 into 3 is 12, minus 2 into minus 6 is plus 12, 4 into minus 2 is minus 8. So c dot d is equal to 16, and the magnitude of c is equal to 6, and magnitude of d is equal to 7. Now we know that, as we write down that c dot d is equal to magnitude of c into magnitude of d into cos of theta. So 16 is equal to 6 into 7 into cos of theta. So we can find out the theta by using calculator, which is 67.6 degrees. Next we have question number 58. For what values of a are the given vectors a and b perpendicular? So we have to find out the value of this scalar quantity a, so that the given vectors are perpendicular. Now we know that the two vectors are perpendicular if their dot product is 0. So we will find out the dot product of a and b and put that vector to be 0. So a into 2a is going to be 2a square, minus 2 into plus a is minus 2a, plus 1 into minus 4 is minus 4. So I will take 2 common from this equation, that is a square minus a minus 2 is equal to 0, and performing the factorization we find out a is equal to 2 and minus 1. It is not necessary to perform the factorization because you can solve this quadratic equation by any method. A square minus a minus 2 is equal to 0, and to solve the quadratic equation you may use factorization or completing square method or even the quadratic formula. And here are the two possible values of the scalar a, which are going to make the given vectors to be perpendicular. Next we have question number 59. We have to find out the acute angles which the line joining the given points makes with the coordinate axis. Now we know that for finding out the angles between the given vector and the axis, we just need to take the dot product with the corresponding axis or the corresponding unit vectors along the x, y and z axis. That is, we will take the dot product with a unit vector I, unit vector j and unit vector k in order to get the angle between the vector and the corresponding axis. But before, in order to find out the vectors, what we have to do, we have to join the points 1 minus 3 2 with the point 3 minus 5 and 1, and we know that whenever we have to join the 2 points, we will find out the corresponding vector by performing terminal point minus initial point. So we will perform final or terminal point minus initial point so that we can find out the corresponding vector or the line which is joining the 2 points. So here we have performed terminal point minus initial point, and we get the vector c as 2i cap minus 2j cap plus minus k cap. So we will find out its magnitude, which is going to be 3. And now for the angle of this line or this vector with x-axis, what we have to do, we will take the dot product with the unit vector I, because unit vector I is along x-axis. It will be equal to magnitude of c into 1 into cos of theta, as the magnitude of unit vector I is 1, and this is going to be the corresponding angle. If we have to find out the direction cosines, then this will be the answer, that cos of theta is equal to 2 by 3. You do not need to perform cos inverse and find out the angle, but if you have to find out the angles for with the corresponding axis, we have to perform this operation or this step as well. Otherwise, c dot j, then cos of theta is equal to 2 by 3 will be the corresponding direction cosines. So here we have taken the dot product with I first, then for y-axis we have taken the dot product with j, and for z-axis we have taken the dot product with unit vector k. So next you have to perform question number 60 on your own, because this is the same one as we have performed 59. We just find out the cos of theta, not theta is equal to cos inverse, just cos of theta. That is, we will find out the vector first by performing terminal point minus initial point. Then we will take the dot product with unit vector I, unit vector j, and unit vector k. So you will perform question number 60. Next, you have to perform question number 63. Find the projection of the vector 2i minus 3j plus 6k on the vector. So we have already performed it, how we can find out the projection of the vector. So you have to perform question number 63. Next, we have question number 64. Find the projection of the vector this on the line passing through the points this. That is, we have to find out the corresponding vector first, and then we will find out the projection. So how we can find out a line joining the 2 points? Again, we have to perform terminal point minus initial point. So here we have performed or find out the vector C as minus 2, minus 2, minus 4, minus 4, minus 3 is minus 7, then 3 plus 1 is 4. So here is the resultant C joining the given 2 points, and here is the magnitude of this vector, which is 9. Now we will find out the unit vector in the direction of C by performing the, or by dividing the vector with its magnitude. So here is the unit vector in the direction of C, because if we have to find out the projection of any vector in the direction of the vector C, we have to take the dot product of this vector with the unit vector C. So now we will take the dot product with the unit vector C, and here is the resultant answer. You have to perform question number 65, as this is quite simple. We have to find out a unit vector perpendicular to both A and B, and we know that A cross B is the vector which is perpendicular to both A and B. So you will just find out the cross product, and then you will find out the corresponding unit vector. Then we have question number 68. Show that the vector A and vector B and vector C are mutually orthogonal unit vectors. So mutually orthogonal unit vector means their corresponding dot products must be 0. At first you will show that these are the unit vectors by finding out their magnitudes, which is going to be 1. The magnitude of A will be 1, magnitude of B will be 1, and magnitude of C will be 1. So here you can also see as the magnitude of A will be it is going to be 4 by 9 plus 4 by 9 plus 1 by 9. So 9 by 9 is equal to 1. So magnitude of A, B and C will be 1. And next we have to show that their corresponding dot product is 0, so that A is perpendicular to B, B is perpendicular to C, and A is perpendicular to C as well. So here I have checked the corresponding dot products. A dot B is 0, A dot C is 0, and B dot C is also 0. So these are mutually orthogonal unit vectors. Next we have question number 69. Find the work done in moving an object from a straight line from this point to this in a force field given by this. Now we know that the work done can be find out using F dot R, where R is the displacement or the position vector. So as we are joining this point to this, so again we have to perform terminal point minus initial point. So 2 minus 3 is minus 1, minus 1 minus 2 is minus 3, 4 plus 1 is 5. So here is the corresponding displacement vector, and we will take the dot product with force so that we find out the work done over here. Next you have to perform question number 78, 79 and 80, as these are just simple steps that you have to perform the operations that are represented over here. For example, in question number 78 you have to find out this cross product. That is, you can perform J cross I and J cross K, or you can perform the form, or the, as we know that IJK, or the determinant IJK with the 0, 2, 0 and 3, 0 and minus 4, and you will get the same answer as earlier. So you have to perform question number 78, 79 and 80. Next we have question number 83. Find the area of a triangle with vertices at the given 3 points. So we have to find out the area of the triangle. So we are given with the three vertices, the point A, point B, and point C. So at first we will find out the sides or the two sides, so that A, B, and AC. So A, B will be equal to terminal point minus initial point, that is B minus A. So 1 minus 3 is minus 2, minus 1 plus 1 is 0. So J component is 0, minus 3 minus 2 is minus 5. So here is the vector AB, and here is the vector AC. 4 minus 1, AC 4 minus 3 is 1, minus 3 plus 1 is minus 2, 1 minus 2 is minus 1. So here is the vector AC. Now we know that area of the triangle is the magnitude of the cross product of the two vectors along the sides of the triangle. That is, I have to find out their cross product first, which is going to be the determinant ijk, minus 2 0 and minus 5, 1 minus 2 and minus 1, and then we will find out its magnitude, half base into height. As we know that the formula is half base into height, that is half into magnitude of the cross product of the two vectors. So it is equal to 1 by 2 square root of 165. Next is question number 84 that you have to perform on your own, because it is quite simple. You have to find out a vector magnitude 5 perpendicular to both A and B. So at first you will find out a vector which is perpendicular to both A and B, which is basically the cross product of A and B, and you will find out the unit vector. And as we have to make the magnitude 5, so you will multiply that unit vector with 5. So you have to attempt this question. Next you have question number 90 that you are going to solve on your own, because this is again a simple question. Find the volume of parallel pipe whose edges are represented by the vector A and vector B, so and vector C. So we know that the volume is basically equal to the scalar triple product of A, B and C. So you will write down the vector A, vector B and vector C, and then you will perform this determinant to find out the volume, required volume. Then we have question number 92. Find the constant A such that the given three vectors are coplanar. So here we are going to solve question number 92. We have to find out the constant A such that the given three vectors are coplanar. Now we know that the vectors will be coplanar if their scalar triple product is 0. So in order to make the scalar triple product 0, we have placed the scalar triple product is equal to 0. That is by taking the first row to be the components of the first vector, second vector and the components of third vector. Now we will expand this and we will get the equation 7a is equal to minus 28, and we can find out the value of a, which is equal to minus 4. So this was chapter number 2.